Good afternoon, everyone. My name is Ricardo Dias, and I'm a senior software engineer at SUSE, working on the enterprise storage team. Today I'm going to talk about a new feature present in our product, which allows to the asynchronous replication of RADOS block devices. Okay, so I will start with some motivation. So nowadays, everything that we do on computers generates data. Even if you are just browsing in the internet, all your clicks, all your actions, everything is being stored somewhere, right? And data is a really important asset for companies. And as you all know, data is growing in a very high rate, and to handle this so quick growth, we need storage solutions that can easily scale and be cost effective and at the same time fast. So our SUSE enterprise storage product, which is powered by the Ceph distributed storage system, is a solution that is capable of satisfying this requirement. The Ceph storage solution, it's a highly resilient and self-managed system and provides a unified system across several interfaces. So it exposes an object interface, a block device interface, and also, more recently, a file system interface using CephFS. So for this particular talk, we will focus on the RADOS block device interface. So the RADOS block device exposes a block device abstraction over a Ceph cluster. Okay, so these block devices are thin provision, as they are actually they are contiguous sequence of memory that are split in small fixed size objects that are stored in the Ceph cluster. These block devices are resizable, and it also supports snapshotting and clones. And there are actually several clients making use of RADOS block device, such as the Linux kernel model, where you can actually have a mount point over a RADOS block device, or you can access using iSCSI, or you can actually create virtual disks in QEMU or OpenStack Cinder. So Ceph is fault tolerant. So Ceph is a single cluster, usually located in a single data center, and it takes care of replicating data, and it's fault tolerant. So it tolerates up to n-1 failures. But the problem is, what happens if all the replicas fail? So, and this can actually happen in the real world. In the real world, we can actually have earthquakes, we can have natural disasters, we can have fires, we can have everything, okay? And the only way to resist, to keep our data safe in the presence of these catastrophes is to store the data or a copy of the data somewhere else. So this is where disaster recovery techniques comes in. So the main technique to recover from a disaster is to do backups. Okay? So backups is the most important. It's very important to have up-to-date backups so we can actually recover from disasters. But as we all know, backups are something that it's really boring to do, and most people forgot to do. So for backups to be actually usable, we need to satisfy some set of requirements. So backup should be automatic, right? We don't want humans to intervene when making a backup. We all know that humans fail a lot. We want data to be stored, or the backups to be stored in a very distant place, so we can actually tolerate natural disasters, for instance. We want the backup system to be easily manageable. So if it's too complicated to configure the backup system, it's also very easy to misconfigure the system, and in the end, things will not work. And backups should also be invisible to users. What this means? It means that users should not see any change of behavior of the system if the backups are actually being processed or being done. And at last but not least, the recovery from a backup should be at least semi-automatic. Okay? So it should be a simple operation, right? So given this set of requirements, what can Ceph do for us? Okay? And it actually can do a lot with the new feature of RBD mirroring, which will allow to create backups of RBD block devices into distant places in an asynchronous way. So I will briefly present some details about how Ceph actually works, and then I will focus on the implementation, well, not the implementation, but at least how the RADOS block devices work. And then I will proceed to presenting you the new feature RBD mirroring. I will present a high-level overview of the feature, and then I will go into more depth to some of the implementation details. Okay. I will finish the presentation with just some future features that are actually being, they are currently being implemented right now upstream. Okay, so let's start with Ceph. So Ceph is a distributed storage system. It's the heart of SUSE enterprise storage product. And it's a highly resilient to failures and self-managed storage solution. So as I said before, it provides different interfaces over to store data. So you can store data as objects. You can look at your data as a block device, so a contiguous sequence of bytes, or you can work with Ceph using a file system. In this case, CephFS. The data is stored or is distributed across several nodes, and whenever you need more space, you just need to add more nodes. So it can actually scale pretty well in the horizontal. Okay? And all of this, and you can do this, it's highly scalable, mostly due to the crush algorithm, which is an algorithm that will try to uniformly distribute your data across all the nodes, all the servers that have the disks. So here I represent the design of the architecture of a Ceph cluster. So usually we have a set of servers which we call OSDs. Each OSD usually corresponds to a disk, so where data is actually stored. Right? And we can actually have more than one OSD in each physical server, right? We can have more than one disk. So we also have a set of special servers called monitors, which monitor the status of the cluster. They also coordinate the membership of OSDs in the cluster and also act as the entry points for clients in the cluster. So all clients that need to talk with the cluster, they will talk first with the monitors, and then the monitors will give them enough information for them to talk with the OSDs. So all the clients talk with the underlying storage using the RADOS common object store. So RADOS is a library. Okay? It's the base library that it's used by all other interfaces. Okay? This library provides an object abstraction. Okay? And every other interface that provides different abstractions, they are actually mapped to these two objects and use librados to communicate with the underlying storage. So now going into more depth in the case of the RADOS block device. So RADOS block device provides the block device abstraction for users. These block devices can be used as mount points using the kernel module for RBD. We can use them as virtual disks in virtual machines, or we can access them using SUSE. In the RADOS block device domain, block devices are called images. So throughout the remainder of the presentation, I will talk about RBD images, but they are actually block devices. So these images are thin provision. So they are actually, they are only occupying the space that they are really using. Even if the image is created with 100 gigabytes and we are only using 1 megabyte, we will be only using 1 megabyte, or we'll only be occupying 1 megabyte on the underlying storage. As I said before, all these interfaces communicate with the underlying storage using librados. And the implementation of RBD is under a library called librd, which will communicate with librados. An important thing that everyone should know is that the underlying storage, the OSDs, know nothing about RBD. Okay? So the block devices abstraction is completely implemented on the client library. So Ceph, the OSDs, the object store, doesn't know what it is, an RBD image. It's the responsibility of librd, the RBD client library, to map image operations like read and write, resize, delete, to map those operations into OSD operations over objects. The librd also implements a memory cache for the client to speed up operations. So the important thing to return is that the image abstraction only exists at the client side. Okay, so the architecture is very simple. So the applications like QEMU, OpenStack, the Linux kernel, iSCSI, will talk with the librd library and also with the librados. And librados will communicate with the OSDs, the underlying storage, where the data actually will be stored. So, as I said, so in librd, there's the notion of image and also the memory cache. And the applications will issue operations using librd. They can issue create, read, and write operations. And for instance, a read, when an application issues a read operation, it will make a call to librados to go fetch the corresponding object where the data resides. Unless, of course, the data it's in its memory, in lib RBD memory cache. In that case, it doesn't need to communicate with the cluster. In the case of a write operation, writes always go first to the cache. Okay? So whenever you make a write on the block on a RADOS block device, you will the implementation will make the write on the memory cache. Okay, and periodically, or when the cache becomes full, those writes are eventually flushed to the underlying storage. Okay. So it's a very simple model, nothing. Of course, this is an oversimplification of what is happening, right? But there's nothing here that you wouldn't expect. Okay, so back to the start. We were talking about how to tolerate big disasters, right? How we can actually create backups, store the backups in very distant places in an efficient way and easy way. So, and we were trying to answer the question of what can Ceph do for us. So we know that RBD images are stored in a single cluster, and they are stored in a single data center. So what Ceph will give us is a feature called RBD Mirroring, which will allow to asynchronously mirror RBD images to a remote cluster. Okay. This new feature is available since Ceph Dual version, okay? And it's a technical preview in our CES 3 and in the new CES 4 release. So how does RBD mirroring work? Okay, so imagine we have the primary site. Primary site is where the primary cluster resides. It's the data center where users will actually interact with, create RBD image, make operations. Okay. And we have a secondary site where we are going to store all the backups of the primary site. Okay. So in the primary site, we have clients accessing it. We don't have clients on the secondary side. And the core component of RBD mirroring that actually performs all the work and to mirror images is this new service called RBD-Mirror Daemon, which executes inside the Ceph cluster on the secondary site. Okay, so the RBD-Mirror Daemon is running on the cluster that will store the backups. Okay. So, and this RBD Mirror Daemon will, what it does, it's a very simple operation. It goes to the primary site and pulls data from the images and stores it on the secondary site. Okay, and this creates the backup. So this model is so simple that it can actually be composable, and we can have a third site, okay, also with an RBD mirror daemon that is also asynchronously replicating the data from the primary site and storing on this third site. Okay, so you can actually have more than one backup in the case there is a really big catastrophe. So now, what happens if there's a failure? So if the primary site fails. So in this case, the primary site fails. The RBD mirror daemons will eventually see that they cannot connect anymore to the primary site. So they will stop mirroring. And now we need to, the system administrators need to make the decision of what to do. So, and they can actually fall back to one of the mirror sites, to one of the backups, okay? And so they can issue a command and make, for instance, in this case, the secondary site to become the primary, okay? And after this operation, after we say that, okay, we are now going to use our backup as the primary source of data, we can let users start accessing these new sites, okay? And we can configure the third site to start mirroring data from the new primary site, okay? So this is how the RBD mirror feature works. So it's very important to understand that the mirroring is asynchronous from the point of view of the primary, right? Because it's the RBD-Mirror Daemon from the other side that is pulling data, okay, periodically to the backup site. Okay, so as I said, it's asynchronous. The RBD daemon fetches data from the primary site and replaces or stores that data that it fetches on the backup site, in the perspective of the RBD daemon in its local site. And a very important issue here in the current implementation is that this RBD daemon needs to have access to all nodes of the cluster on the primary site, because it needs to contact with the monitors, right, which is the entry point for the Ceph cluster, and also needs to contact with the OSD nodes on the primary site, okay? And of course, it also has to have all this access to its local cluster where it's executing. We provide, or we guarantee crash consistency. So the mirrored image will have the same guarantees as the primary image. So we guarantee crash consistency. Sorry. So you at this point you might be wondering if it is the RBD daemon mirror that fetches data from the primary site and stores on its local site, how can he actually decide which data to fetch? So for sure, it will not fetch all the data over and over again and store it on its local site. Okay. So there is, we need another piece on this puzzle for all these features to work, which is journaling. Okay. So for RBD mirroring to work, we need to implement a new image feature, which is called journaling, which has a journal for each RBD image. And a journal, it's just a sequential log of all operations that are issued to an image. Okay. So we log all operations that modify the state of the image. Okay. So we log writes, resize, flushes, and other operations. This is a sequential log, okay? And this journal is also stored as objects in the Ceph cluster, okay? So if now we have a journal, the processing of write operations is a bit different than when we don't have a journal, right? Because without a journal, writes were really straightforward. The RBD library would just write them to the memory cache, and when the cache was full, it would just flush those writes to the to the OSDs. But now with the journal, things are a bit more complicated. So when a client issues a write operation into an image, it first has to generate a unique position number on the journal. Remember, the journal is sequential. We need to give them what is the position in the journal for these new operation. So after generating this number, this position, we tag the operation. We create a journal event with the operation, the data of that operation, plus its position on the log. And we send this event, so we send this event to we persist it, so we send it to the OSDs. We make a write. But this write operation, so when we send the journal event to the OSDs, we make it in an asynchronous way. So we don't wait for it to finish. Okay? And we just send, so write whenever you want, and we proceed to write the data on memory cache, and we just return to the client. Okay? And this avoids to double the latency of write operations. Because while without journal, the operation was just a memory operation, a write on the memory cache, which was really fast. With the journal, if we were going to wait for it to be written in the OSDs, we would increase the latency not by the double, but we would increase by a very big factor. So all of this works because whenever the cache is full, and we need to evict some of the entries, we cannot evict the entries before we receive the confirmation that the corresponding journal event is actually persistent. Okay? So eventually, we might get to the state where the client will have to wait in the case of if the cache becomes full and needs to wait for in-transit journal write operations. So, so now that we have the journal, the life of the RBD daemon, the RBD Mirror Daemon, it's much easier. What the RBD mirroring does is just it reads the journal from the primary site, okay, and it gets all the new events since the last time that he accessed the journal. Okay. And he gets those events and replays them on the backup store. Okay. So all of the work, basically, besides the journaling part, is done by the RBD daemon. The daemon can run on a server of your existing Ceph cluster, and as I already said, it requires access to the primary site, to all nodes. It performs all the mirroring work, so it reads the journal entries from the primary site and replays them on their local cluster. And they are also responsible for the bootstrap. So you can activate the mirroring process to existing images on your cluster. Okay? Even if when those images were created, you didn't activate the journaling, you can do it after creating them. So what the RBD daemon does to bootstrap is just it looks at an image, it creates a snapshot, it copies that snapshot to its local cluster, and then starts replaying from that point in time. Okay? This is called the resync operation. And it's also the responsibility of the daemon to handle the failover operations. So we can demote a primary site to a secondary site and promote a secondary site to primary. Okay. So in case, we have actually two cases. One is that it's more simple. So the administrator decides that we should move all the load to the other side. So we have the primary and we have our backing side, the secondary, but we want to move all the load to the secondary. So what we must do first is tell the RBD daemon to saying that we want to demote the primary. Okay, so we don't want the primary to be the primary anymore. And after that, so there's no primary on the system, change one of the secondaries to be the primary. Another situation is when you have a real failure, so the primary site becomes inaccessible. Okay, you don't have a way to access it. And in that case, you can force one of your backup stores to become the primary. Okay, and in this case, you can imagine that if the primary site becomes available again, now you have two primary sites, but this is taking care on the code and requires human interaction to solve this. So, and one of the ways to solve this is, so when the failed image becomes available, you demoted it to secondary and force a resync. So get all the data from the new primary site to this one and start mirroring. Okay. So now I will just show some of the commands that we use to manage the RBD mirroring feature. So how to activate it with real command line commands. So first, we need to use RBD mirroring daemon. RBD mirroring feature. We have to make some preparations on the primary side. Okay. So I'm assuming I'm on the primary side. I have a pool name called RBD, and I have an image called foo image. The first thing you have to do is enable the journaling feature. And actually, this command has a typo. So there's journaling twice. You can erase the first journaling on the command. So you just say, I want to activate journaling for that particular image. Okay. Then, after this, I have to, for RBD mirroring to work, I need to activate it at the pool level, not only on the images. Okay, I will also have to say which images are supposed to be mirrored, but I have to activate it at the pool level. And this is just to help us when we actually want to mirror all the images in the pool. So we don't want system administrators to do this for each image in the pool. So what you do is we have two modes of mirroring for the pool level. We have the pool mode, which is not the best word since it's kind of confusing with the pool. So there is the pool mode mirroring, which what it says is that all images should be mirrored. So after activating the pool mirroring mode, any image that you create on that pool will automatically have journaling activated and also the mirroring feature activated. Okay. The other mode that you can set for the pool, it's the image mirroring mode. And the image mirroring mode allows you to set the mirroring for each image individually. Okay. So nothing is automatically anymore. If you create an image, you have to enable the journaling feature and say that you want to mirror that image. And for an image, if I want to say that I want to enable mirror for that image, I just, as I said, this only works if the pool is in image mode, right? Because if it's in pool mode, every image gets the mirroring feature enabled automatically. Okay. Okay, that was everything you have to do on the primary side. Now, for preparing the backup cluster, which I call secondary cluster, once again, I'm assuming I have a pool called RBD, and I'm assuming that the name of the primary cluster is called primary cluster. So in the backup store, I also have to activate the mirroring mode at the pool level. So I can just put it on pool mode. And then I need to I need to set on the cluster from which cluster the RBD daemon is supposed to get data from. Okay? So, and this operation is called add peer. And the peer information is just the name of the cluster. And this name of the cluster should correspond to an existing file called the name of the cluster.conf, where you have all the monitor addresses of the primary site plus the keys and everything. Okay? Usually, we call that the ceph.conf file, which has all the information for connecting to a cluster. But in this case, instead of ceph.conf, we put the name of the cluster.conf, which will have all the information to connect to the primary site. Okay. So when you do this, when you add peer, and you should be already having the daemon running on your cluster, the daemon is always watching for this peer list, okay? And it will, as soon as you add the peer, the daemon will start working. So what the daemon will do is, okay, I have a new peer. I'm going to connect to the primary site. I will list all the images from the pool, from all pools, and I will check first which pools have the mirroring mode enabled, either pool or image, and then look at the images, which ones have the mirroring enabled, and for each one, we'll start making the mirroring. We'll start mirroring. Okay? Okay, so they will start creating the images on the local cluster, creating the snapshots, copy the snapshots, and start replaying journal events. So it's actually very easy. So the administrator only has to add the peer, and the daemon will do all the work. So for the failover procedure, the commands are also very simple. So at the primary cluster, we just tell that we want to demote that image. Okay, so at the primary cluster, the full image is the primary image, and we say no, I don't want that anymore. I want to demote it. This will make, if there is any daemon fetching journal events from this image, it will stop immediately. Okay. And then I can go to the secondary cluster and say, oh, I want to promote this image, which was a mirror. I want to promote it to be the primary. Okay. So, and that is actually all that, almost all the essential about the mirroring feature. So it's nothing very complicated. It's actually easable to configure and to put it to work. So there are a couple of features that are being currently implemented. In the current implementation of this feature, we only support one RBD Mirror Daemon per cluster. As this might not scale, of course, because if you have several pools with hundreds of images, a single RBD daemon might not be enough to mirror all the images. So we are currently implementing the RBD Mirror Daemon high availability, which will support several RBD daemons on the same cluster. So this will allow two things: load balancing of the mirroring process, and also fault tolerance for the daemons. Okay? So if one daemon fails, the other daemon can actually steal the work that the other was doing and starts replaying all the events. And there is also another feature that is called consistency groups that will allow to have crash consistency across multiple RBD images. And the essential idea is that you get a single journal for a group of images, okay? And that you will get crash consistent across several images. And I don't have anything else, so any questions? Sorry, the back.
Is there any interface to monitor how the mirroring is going, or is there any command?
Currently, there is a couple of commands where you can list all the images that are being mirrored, and their status, if there's a failure or not, but nothing more than this. So just the status, this image is being mirrored from that part, and it's currently working fine, or if something is wrong. That's it.
You cannot have a percent of how many data have been replicated, or the size of the view, something like that?
Not yet.
Okay.
Not yet. Please.
The pool name, the primary and secondary, do those have to be the same? I noticed you had them the same there, but
good.
Is that a good?
So let me think a bit, because I only remember the first implementation. I don't know if it was changed, but I think it has to be the same. Yes. Or no, sorry, it doesn't have, because when we add the peer, we add the peer to a pool. And so it will start to, and when we add the peer, we give them the name of the cluster and the pool. And it will start fetching everything for that pool where we add the peer. But this is something that it might change in the future.
If they're different, then how does the end user that's using it know? Then they have to know the code.
Yeah, exactly. That's the main problem. That's why probably it will be changed in the future, because it can create some confusion. So, but.
So you mentioned that the journal units store as objects. What's responsible for cleaning them up?
Right. So. Okay. So the question was who actually cleans the journal, right? So the journal, whenever a daemon is getting events from the journal, it is registered at the journal. So the journal knows how many daemons are getting events, and they know for each of these daemons which was the last event that they fetched. So at some point, they know which is the cut point there where they can release the past events. So they just need to look at which daemon it's more behind, right? And every event that is past that point, you can just erase it.
As a follow-up, what happens if the secondary goes down and stops fetching the objects?
So the primary continues to work, right? So if the secondary just stops, well, currently we don't have any monitoring, so the administration, I don't know how the administration will know that the backup store just stopped mirroring, but it will have to solve the problem, then fix it and start the mirroring again. Make the resync all the images and start mirroring again.
Well, I guess the question I'm asking is, so we have, ultimately, if the secondary stops asking for images, or asking for objects, then you can fill the entire disk. What happens on the primary when that happens? Does the primary say, all right, this mirror is gone, I need to continue because I still have users, and the secondary needs to resync from the beginning, or does it just wait?
That's a good question. I don't remember what is the current behavior. I remember to ask myself the same question, but I don't remember what is the current behavior on the implementation. Yes, please.
Do you have any measurements of the impact on the primary side on doing journaling and so?
Yes.
Performance or in disk usage?
Yes. So the first version that we tested, we found out that the journaling was actually placing a very performance penalty on the primary. So we measured, our first measurements were about between 4 and 5 times slowdown. So actually our team started to look at the code and trying to optimize it, and we could reduce to half of it, so only to 2 times slowdown, and we made further optimizations that were already merged upstream, but we still haven't made new performance experiments to check what is the current over. Of course, we are expecting to have some slowdown, but something non-significant. Okay.
About the disk usage, maybe it's related to was asked before. Where is the journal stored and how may it be?
So the journals are stored on the OSDs. They are like other objects on the OSDs. So you can even configure to store the journal objects in another pool. Okay. For instance, if you want to configure somehow that pool to only store things on SSDs to be more faster, you can do it.
You said that it's a preview, and so when this will be officially supported in the test project?
Well, I don't have an answer for that yet.
What was the question?
When will it become production ready? In which version?
Do I have to install anything that Daemon is running, or is it already installed per default?
It's already, in our SES product, there's a package for the RBD Mirror. I don't remember if you install Ceph, it will become, if it will also install that package. But yeah.
Separate RPM?
Sorry?
A separate RPM I have to install anyway. I just verified it's there and that's fine.
Yeah, that's it. And you install it, and it will start running. Yeah. There's a system D scripts for it. Any more questions? No? Okay, so thank you very much.